Hi everybody, these are the notes for our first topic in Unit 1. The unit is called Functions and Their Graphs, and this topic is a review of linear equations. Everything in here is something you should have seen in previous years, so if it seems familiar, just know this is a review. But if this does not seem familiar, this is going to be a great resource as we start working on some projects with linear graphs and slope-intercept form in particular. All right, let's get started. So our first kind of major question is, what is a linear function? What is a linear equation? And so a linear equation, a linear function, I'm going to have it have three things to it. The first is that a linear function has two variables. So it's an equation with two variables. And the second thing is that it's always going to be a straight line. The third, I just think it's important to remember this piece. It's not really definitional, but a linear function always represents constant change. So if you thought about physics before, a linear function is not a car that's accelerating, but a linear function is a car that's driving at a constant speed. That's how I kind of think about it. And linear functions can look like either of these two over here. Y equals x plus 3 is a linear function, and it looks like this. We'll go over how to graph them a little later, don't worry. But so that's one example of a linear function. And y equals 5 minus 3x would look like this. So they're straight lines. They have equations that have two variables. So our two variables here are y and x, and it represents constant change. So the slope of the line is always constant. Speaking of slope, our next question is regarding a reminder of what slope is. So slope is how much a line rises or falls as you move left to right on your graph. A lot of you have learned this perhaps as rise over run. It could also look like this, rise over run. And one way we find slope is, instead of using an equation, actually looking at a graph and trying to figure out how much the slope is changing. I'll do that first. So if we wanted to just use visual ideas here to find our slope, we would identify 2 points on the graph. Here's 1 point. This point is at the spot -2, 0. And we also have a point here that is at the position 0, +4. So if I wanted to just use rise over run, I could do the following. Rise over run. And I can see that my line is rising by 4 in this section. So my rise is +4. And my run, which is always left to right, is 2 in the same section. I'm actually going to use a different color there. My run is 2, +2. And so if I simplify that, I should have a slope of +2. Sometimes we don't want to draw it out, or the graph is a little unclear, or we've just been given points. So we also have an equation to calculate the slope, especially when we have points that are very far apart or we don't want to do that counting. The equation for slope looks like this. To do this, you need 2 points. So we're going to say that we have a point x1, y1, and another point, which we'll call x2, y2. So we need to have 2 points on our chart or on our line. The equation for slope is then m, which is always what we call slope, is equal to 2 differences. The first difference is y2 minus y1. And the second difference is x2 minus x1. So we take 1 point and we subtract our y value from our previous point, and we do the same for the x's. Notice this kind of correlates to rise over run, the change in y, the difference in y being how much the graph is rising, and the change in x, or the difference in x, being how much the graph is running. So we can also just do a quick example over here using that slope equation. So if we're using the same 2 points, I'll first identify in color what those 2 points are. So we have the point 0, 4 and the point -2, 0. And I want to fill in my equation for slope. It's going to be, y2, which is -2, minus y1, which is 4, over, oh no, of course I already made a mistake. It's going to be 0, which is y2, minus 4, which is y1. This is why you should always correct me when I make these mistakes. And then below, we're going to have x2, which is -2. That's where that comes in, minus x1, which is 0. And if it's helpful, I'll put those above here. x1, y1, and x2, y2. When we simplify this, we're going to get -4 over -2 minus 0 is -2. And after we cancel this out, we will get a slope of +2 again. So both methods should yield the same result. All right, that is slope. We're going to go on your paper, you're going to have the notes keep going below, and mine are a little bigger so I can write more clearly on video, so I'll flip mine over. So just a quick check for what slopes can look like. Remember that the slope is going to be the number in front, the coefficient in front of our x variable, but you can see that slopes can be positive. So this is an example of positive slope. We have a +1 and our graph is rising from left to right. We can also have negative slope, so -4, and our graph is going down from left to right. This graph here has no x, so you might think of this equation as y equals 0x minus 1. There is no x variable, and we know that our linear equations have 2 variables. And so our slope is kind of missing, or it's equal to 0. When our slope is 0, this ends up being a horizontal line. It's horizontal, and our slope is equal to 0. Think about it as being our slope we're not rising at all. We have 0 rise. We're just going straight, and so we have a 0 slope. In this example, forever, we have an x coefficient, but we're missing y. This is a weird case where we actually have all rise and no run. And so here we say our slope is undefined. And we end up with a vertical line.